Alright, in this example, we're going to be applying the mole formula in a slightly different way, where we are now looking for mass given moles, and given that we can find the molar mass. So in this example, we are asked for what is the mass of 0.7 moles of H2O2. This is also called hydrogen peroxide. So the first thing I like to do when tackling these kinds of questions is that first we're just going to make a data list so we can determine the givens and our unknowns. So N means moles, and we know that that is 0.7 moles. We're being asked for the mass, so that is an unknown, lowercase m, and then the molar mass, that's also an unknown. We have to determine that, but we can do that very easily using the periodic table. So our first step is we're going to solve for the molar mass. So the molar mass of H2O2 equals the molar mass of each element on its own compared to how many of them there are in the compound. So there's 2 each of hydrogen and oxygen, so we can say that's 2 times the molar mass of hydrogen plus 2 times 15.9994 grams per mole. Remember, we always need to have units. Always need to have units in our formulas, in our solutions, for full marks. Units are very important. So when we type all of this into our calculator, and we're looking for our final solution, we will see that the molar mass of hydrogen peroxide is 34.01468 grams per mole. And see here, I'm not going to round this yet. I want to carry as much information as I can until the very end of the problem. So now if we look back over here, we know that we still want to find mass. So that's still our unknown. So we got to think to ourselves, okay, what equation has all 3 of these variables in it? And that would be our mole formula, where we know that moles equals mass over molar mass. We have to isolate m on its own to be able to solve for the mass, and this is something that we can do just with a little bit of algebra. So if we multiply both sides by the molar mass, then the molar mass would cancel out on the right side of the equation because anything divided by itself is 1. And then we are left with the expression that molar mass times moles equals mass. Alright, now we can plug our variables into our equation and solve. So mass equals moles times molar mass, that's what we know. 0.7 moles times 34.01468 grams per mole. And then our final answer there is going to be 23.810276 grams, or we can round that to 23.81 grams. Something to pay attention to as well. If you ever want to make sure that you're on the right track with regard to algebra, just pay attention to your units. Because units, they multiply by each other as well. It's called dimensional analysis when we're looking at the units. So moles here is in the numerator of the units for this term, but it's in the denominator of the units here for this other term. So moles themselves as a unit would cancel out, and that's why we're left with only grams. So that's why the final answer here is in grams. And that's how we know that mass has units of grams. So again, our final answer there. Therefore, the mass of 0.7 moles of H2O2 is 23.81 grams.